So in this example, we're asked to calculate the magnitude and direction of the velocity and acceleration at point A. We're given the equation of the slope that the skier is going down on. We're given the velocity at 6 meters per second squared, and we're given the acceleration in the tangential direction, or v dot, is 2 meters per second squared. So we see that we're given the path, the equation for the path, and it's asking for normal and tangential things. So this is clearly going to be an NT problem. And so right away, we know that in NT coordinates, the velocity is v times the unit vector in the tangent direction. The acceleration is v dot in the tangential direction, and it also has an acceleration of v squared over rho in the normal direction. So I'm going to highlight in yellow the things that we don't know. So we don't know the direction of the unit vectors, and we don't know this radius. But what we do know, highlighted in green, is we are given that the velocity is 6 meters per second squared. The acceleration in the tangential direction is 2 meters per second squared. And again, here's that velocity of 6 meters per second. So this is going to boil down to finding the unit vectors in the normal and tangent direction and figuring out the radius of curvature at point A. So let's start with the unit vectors. And so here's the parabola. And so remember that the unit vector in the tangent direction is tangent. And when I first did this, I made the mistake of pointing the tangent vector uphill. But remember that the tangent unit vector is in the direction of motion, and obviously the skier is going downhill. The normal vector, remember, is perpendicular to that and always points towards the center of the curve, which is that way. So that's u normal. Okay, so how do we calculate these? Well, we know the tangent vector is the slope at point A, right? Because the slope is tangent to the curve. So at A, the slope, dy dx, okay, is d dx of 1 over 20x squared. So the slope is given by the equation 1 over 10x. And the slope at A, which is at 10 meters, is dy dx at 10 is 1. And so that's easy. The slope is 1, which means the angle is 45 degrees. So let me do that. 1 to 1. That would make this length root 2. So the unit vector has a length of 1. And so it has 1 over root 2 as its x and y components. That's u tangent. U normal is going perpendicular to that, which is still 45 degrees. If it's a length 1, it's 1 over root 2 and 1 over root 2. That's u normal. And so the normal vector is going in a negative x and positive y, 1 over root 2. The tangent vector is going negative x and negative y, 1 over root 2. So probably the hardest part of this problem is finding the radius of curvature. It's sometimes given, it's not here. And so when it's not given, you're going to have to use what you learned from calculus. And the radius of curvature is given from calculus as 1 plus the slope, which I'm going to do y prime as dy dx, squared, all to the 3/2 power divided by y double prime. So y prime is 1 over 10x, which means y double prime is 1 over 10. And at x equals 10, y prime equals 1, and y double prime equals 1 over 10. So the radius is given by 1 plus 1 squared to the 3/2 power, all divided by 1 over 10. And when you plug that all in, you get 28 28.28 meters. And so we're ready to go. And so let's plug everything in. Let's do the velocity first. So the velocity is 6 times the tangent vector. So it's 6 going down at 45 degrees. Okay? The acceleration that's given by v dot, which was 2, in the tangent direction, plus v squared over rho in the normal direction. And so plug that in, 2 going down at 45 degrees, plus 6 squared over 28.28 in that direction. So that's going to equal 2 in that direction, plus, and that's going to be 1.27 in that direction. So I'm going to proceed from here a little different than what the book does. I'm going to break these vectors into their x and y components. So that's going to be 2 times minus 1 over root 2I minus 1 over root 2j. Okay, so that's a unit vector going down to the left at 45 degrees. Plus 1.27 times minus 1 over root 2I plus 1 over root 2j, and that's the unit vector going at 45 degrees up and to the left. And so all I'm going to do is collect all the I terms and the j terms, then we can figure out the length and direction. Okay, so here we go. That adds up to minus 2.312I and minus 0.516j. So all I did was I added this to this, and then I added up the y's as well. So if you draw the vector, it goes like this: negative x, 2.312, and negative y, 0.516. And so it's going to the left and down. So I'm just going to use Pythagorean's theorem to get the total length of the vector. And so x squared plus y squared square root equals 2.369 meters per second squared. We need to get that angle. I'm just going to take the arctangent of 0.516 divided by 2.312, and that comes out to 12.6 degrees. So in the end, the velocity is 6 meters per second going down at 45 degrees, and the acceleration is 2.37 meters per second squared, angled down at 12.6 degrees. There you go.